Hello, hello, hello. Good morning, good morning, good morning. I am fine today and happy. I hope you are also fine. I welcome you to another session of our discussion. Today we are looking at mathematics, and the topic is sets. Not only set of numbers. Set of numbers will limit us to only numbers, but we are discussing sets in general. However, set in general covers or goes beyond set of numbers. But our previous ideas on set of numbers will be an added advantage here. So let's begin by looking at the meaning of set. To get that clear, let me share. Let's go start by looking at some few items. Okay, so here we are. We are looking at two set problem. Two set problem is basically the challenges or the problems we face when we are dealing with sets, which involve numbers and the sets here are connected or related in a way. We have different means of representing that. We have looked at some few aspects of that earlier on, but to help us proceed successfully and have fruitful discussion, it would be better we go over some of the issues. So let's first look at the meaning of sets. Hope you remember the meaning of sets. What did we say a set is? We said a set is the collection of well-defined objects. Hope you got that correct. We have examples such as counting numbers. When you want to count something, you start from 1, 2, 3, 4, 5 in that order to the last item. So you see that these numbers are related. If you talk about spoon, fork, knife, we use them for specific purpose. So they are related in a way, therefore we call them capillary. If you take the number 2, 3, 5, 7, 1, 11, 13, 17, and so on and so forth, these numbers also have special relationship, and we said they are called prime numbers. That is because they have only two factors. That is the relationship they have in common. They all have only two factors, meaning no number can divide them apart from those numbers themselves and 1. Then if you also look at 1, 2, 4, 5, 10, and 20, these numbers can all go into the number 20. Therefore, we call them the factors of 20. Can you also give other examples of sets? You can pause here and try to write a few examples. Congratulations, if you're able to write some of them. Let's move on. Let's look at how, or revise how we said set can be described. We said we have 3 ways of describing sets. 2 of them are very common. The third one is sometimes a bit difficult for students to do. So let's start by looking at the first way. The first way is to list the members of the set. So for example, we have P is equal to 2, 3, 5, 7, 11. These are prime numbers less than 10. Prime numbers less than 10. Sorry, prime numbers less than 12. We also have another way of defining the set or describing the set. That's we describe a particular property of the numbers in common or the set itself, or by describing the elements So for example, I said, I described the set P as prime numbers less than 12. Per that description, you are guided, or it is clear for you to be able to list the element of P. So the first way is to list the members. The second one is to define a property of the set or describe the members. The third one is what we call set builder notation. Set builder notation. And this is how it reads. P is equal to X, such that, we pronounce this one, such that 1 is less than X, but X is also less than 12, where X is a prime number. Where X is a prime number. I take it again. P is equal to X, such that 1 is less than X, but X is also less than 12, where X is a prime number. So any prime number that 1 is less than, or that is greater than 1, but less than 12, qualifies to fall or to be part of the group of elements of P. Let's proceed. We have further examples. Here, the sets have been described and the elements listed. We have A is a set of vowels of the English alphabet. You agree with me that the vowels in the English alphabet are A, E, R, I, O, and U. 5 of them. B is the set of prime numbers less than 20. So we have 2, 3, 5, 7, 11, 13, 17, and 19. Then we have C is a set of months with 30 days. April, June, September, November, and in 30 days. D is a set of first 10 odd numbers. That also cover 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. These numbers are different from the one listed in D, which is the set of prime numbers less than 20. D is a set of odd numbers, but D is a set of prime numbers. Take note of that. All prime numbers are odd numbers, except the number 2. Except 2. Let's move on. Exercise 1. I want to see if you can also write set builder notation for the following sets. I have A, the set of even numbers between 2 and 30, the set of triangles, the set of integers less than 10, the set of odd numbers from 1 to 9, and the set of prime numbers greater than 50. At this point, kindly pause the video, try this exercise. When you finish, then you can continue, play the video. Thank you so much for trying that exercise. I hope you had it correct. Okay, let's see whether your answers were correct or wrong. Come with me as we look at the correct answers. Okay, so here come the answers. The first one is the set of even numbers between 2 and 30. This is how it will be described. X such that 2 is less than X, but X is less than 30, where X is an even number. I take it again. X such that 2 is less than X, but X is also less than 30. It says even numbers between 2 and 30, meaning 2 and 30 are not included. This is the set of triangles. So we say X such that X is a triangle, because we have 4 types of triangle. So any of them fall under this description. C, the set of integers less than 10. So you say X such that X is less than 10, where X is an integer. This is the set of odd numbers from 1 to 9. So we can say x such that 0 is less than x, but x is less than 10, where x is an odd number, meaning all odd numbers that fall between 0 and 10 qualify or have been described by this description or qualify to be part of this description. The last one is the set of prime numbers greater than 15. Here we have x such that x is greater than 15, where x is a prime number. So all the prime numbers that are greater than 15, here if you have to list them, you list just about 5 of them. That will include 17, 19, 23, 29, 31, and then you end with 3 of more dots to conclude that. Congratulations if you're able to get it correct. Let's move on to other aspects. Exercise 2, it says list the element of the following sets. List the element of the following sets. So as we saw in the other side, we are here to list the elements of these sets. List the elements of these sets. So here, kindly pause the video and try and list the elements of these sets. Were you able to do that one too? Congratulations. Come with me as we look at the answers. Okay. So here are the answers to the question. The first one says the set of even numbers less than 12. And here are the even numbers that are less than 12. We have 2, 4, 6, 8, and 10. The second one says the set of prime numbers greater than 4, but less than 15. 5, 7, 11, and 13 fall within this category. We have the set of odd numbers less than 8. The set of odd numbers less than 8. So we have 1, 3, 5, and 7. Hope you had that one correct. The set of multiples of 6 greater than 20. So here we have 24, 30, 36, 42. These are the numbers, and it goes on and on because it says greater than 20. It will go on and on and on to infinity. Then we have the set of count numbers between 20 and 30. Here we have 20 count numbers. Count numbers will be 21, 22, 23, 24, 25, 26, 27, 28, and 29. Here you can see that some of the numbers are left out. This set of numbers are only odd numbers. The even numbers have been picked out. So if yours included even numbers, you are right. That is perfect. That should be the correct answer. Congratulations if you're able to get all correct. You are doing well. Come with me as we look at other aspects as well. Now let's look at types of sets. We have different types of sets. This is just to revise what we did earlier. We have what we call a finite set. A finite set is a set that we know its last member. For example, if I give you the set of factors of 8, I hope you can list that. It will include 1, 2, 4, and 8. So we know the last elements there. Infinite sets, on the other hand, we don't know the last member. So for example, if I give you the set of counting numbers, where will you end? We don't know the last number, so it's an infinite set. Then we have a unit set. If we say a set is a unit set, then it means that set has only one member. For example, if I say the set of prime factors of 8, the factors of 8 include 1, 2, 4, and 8. What is the prime number among them? It is only 2. So that set will have only one member, and therefore we call it unit set. So we have finite sets. We know the last member. Infinite sets, we don't know the last member. Unit sets, it contains only one member. Then we have null or empty sets. This is a set that has no member. Universal set is a set that acts like a mother. For example, if I say the factors of 20, there, 20 is what we are actually talking about. 1, 2, 4, 5, 10, and 20 are all obtained from 20. So 20 is their mother. So if you talk about universal set is simply a set that can produce other sets from which we can derive other sets. That is what we mean by a universal set. So universal set produces other sets. Thank you for that. Let's look at something else, and that is cardinality of sets. When we talk about cardinality of sets, we are referring to the number of elements the set contains. So for example, if we talk about the set of factors of 8, factors of 8 are 1, 2, 4, and 8. How many members are there? That is 4. Cardinality is represented by the letter N, as you can see here. So we say N is equal to 4. That means the number of elements in this set are 4. We have 4 elements in this set. Then we have what we call equivalent sets. 2 or more sets are said to be equivalent if they all have the equal number of elements. So if you have 4 elements and I also have 4 elements, then we are equivalent. For example, I have set A containing 1, 2, 4, which is factors of 8, set B containing 1, 2, 5, 10, which is the subfactors of 10. Both A and B contain 4 elements. You can see, as you can see, this one has 4, that one has 4. Therefore, cardinality of A is 4, cardinality of B is 4. We say these two sets, A and B, are equivalent. Thank you for that. Let's move to another arrow. We are looking at the Venn diagram. The Venn diagram. We have looked at several occasions where we were asked to represent a given set on a Venn diagram. Let's quickly revise that. So we can illustrate given set on a Venn diagram if one of the sets happen to be the superset, whereas the others are the subsets. So for example, if you say P is equal to 1 to 10, Q is equal to 1, 2, 5, 10, M is equal to 2, 4, 6, 8, 10. We can confidently say that P is the mother of Q and M. Why? Because all the members of Q and all the members of M are found in P. Therefore, P has become what we call the universal set. To illustrate this on a Venn diagram, we will use a rectangle to represent P. So that is the rectangle. Then each of the subsets, which is Q and M, we will use a circle to represent them. However, to draw that circle, there are 3 ways of drawing the circle. 1, if P is the universal set, Q and M are the subsets, and we have some members common to both P, Q, and M. For example, you can see that 2 is in Q and M. 10 is in Q and M. If that's the case, we say Q intersection M is equal to 10. This means that the two sets have something in common. Therefore, when we are drawing the circles for these two subsets inside P, which is the rectangle, the circles must overlap like this. So as you can see there, we have M and Q overlapping. Then 2 and 10 who fall within the region representing the section where these two circles overlap. So 2 and 10 will occupy that region, as you can see. Then the other members of Q and M who are not part of the intersection or the region in the red bracket will occupy respectively the remaining regions to the left and the right. So if you take Q, we have 1 in Q and 5. If you take M, we have 4, 6, and 8. So they will, 1 and 5 will occupy the extra region of Q, that is this part is meant for 1 and 5. Then this portion here is meant for the remaining members in M who are not part of the intersection. As you can see there, so 4, 6, and 8 are the remaining members of M, whereas 1 and 5 are the remaining members of Q. Now, when we put M and Q together, we call it union. And this is made up of all the members that appear in both Q and M. So this will give us 1, 2, 4, 5, 6, 8, and 10. When we compare all these, or the union of Q and M to the universal set P, you agree with me that there are members in P, which is the universal set, that do not appear as part of this union. We call that complement. So Q union M complement, meaning which members can we add to the members of this union to give us the universal set or the mother set. And that include 3, 7, and 9. So they will occupy the remaining space within the rectangle around the circles. So they can occupy any part of this section here. They can be placed anywhere within the rectangle, but outside the circles. So look at that. So we have the 3, 7, and the 9. That's what we call the complements. Thank you so much. Up to this point, I hope you have enjoyed this particular lesson. Take the following exercise as assignments and make sure you complete them and forward them to me. It contains exercise on what we have just done, or questions on what we have just done, and revision questions on other topics. And I hope you find all of them helpful. So that's one exercise, question 1 to 6 here. We also have question 7 to 12 here. Make sure you pause the video as and when the page changes so that you can confidently copy each question. And then we also have question 13 to 15 here. And the last part is question 16 to 17. This is not the last. And we have 18 to 20. Thank you so much and enjoy the rest of the day. Goodbye.